In our last video, we started having a look at equations that involved fractions. In this video, I want to start having a look at some more complex equations that still involve fractions though. So we're going to dive straight into a few examples. So in this first one, we've got x plus 11 all over 4 plus 8 equals minus 4. So the first thing that I would get rid of here is that plus 8. You can do it in a different order and that's fine, but I'm going to get rid of that plus 8 first. And we know that to get rid of a plus 8, we're going to do the opposite or the inverse. So we're going to subtract 8 from both sides. So that's just going to leave us with this whole fraction on this side. So we've got x plus 11 over 4 equals, and minus 4 minus 8 would give us minus 12. So now we've got this whole x plus 11, that whole thing is divided by 4. So to get that out of the fraction, I'm going to multiply both sides by 4. So that's going to leave us with x plus 11 on that left-hand side. Now minus 12 times 4, because it's a negative times a positive, it's going to give us a negative answer. And 12 times 4 is 48. And then we've just got that one last step of getting rid of that plus 11. And we're going to do that by minusing 11 from both sides of that equation. So we'll end up with x equals minus 59. And again, you can always check these by substituting in. So if we put that in our calculator, we can have, in our fraction, minus 59 plus 11 all over 4. And we've got that plus 8 on the end. And when we hit enter, we should end up with minus 4. Now, if we didn't get that, we'd know that something had gone wrong. But because we do know that x equals minus 59 is the solution to that equation. Let's have a look at the next one. So this one says m minus 2 over 4 is equal to 2m plus 5 over 3. So this one's a little bit different than our first one. Our first one only had one fraction, but this one has two. So if we look at it one at a time, if we want to get rid of this divided by 4 so that that's not in a fraction anymore, we would have to multiply both sides of that equation by 4. So that's going to get rid of this down here, and we're just going to be left with an m minus 2 on the left-hand side of our equation. On the right-hand side, we're going to have 4 times that whole numerator. So we're going to have 4, and then I'm going to put it in brackets as 2m plus 5. So it's 4 times that whole thing, and our denominator hasn't changed, so that's still over 3. Now before I expand that out, I'm going to get rid of this divided by 3, so we've got rid of our second fraction. So to do that, I'm going to multiply everything by 3. Now it's really important here that you're multiplying not just the m or just the 2 by the 3, but you're multiplying everything on this side by the 3. So I'm going to put it in brackets again, so we're going 3 times m minus 2 in brackets. And over on the right hand side, because that times 3 is getting rid of our denominator, that's just going to leave us with that 4 outside of 2m plus 5. So now we can go through and expand all our brackets out. So we're going to go 3 times m gives us 3m, and 3 times minus 2 would give us minus 6. And then expand the other side, so 4 times 2m is 8m, and 4 times 5 is 20. So now we have an equation. We don't have any fractions left, but we do have pronumerals on both sides. We've got m's on both sides of that equation. So we want to get rid of them off one side. We can either get rid of the 3m or the 8m. It doesn't matter which one. Usually we tend to go with the smaller one. So let's subtract 3m from both sides. And we'll be left with minus 6 equals 5m plus 20. Then we're still aiming to get that m on its own. So let's minus 20 from both sides. So we'll have minus 26 equals 5m. And I've run out of room, so I'm just going to go over here. But to get rid of that 5 then, we're going to divide both sides by 5. And we'll end up with m equals minus 26 over 5. Or you could write it as minus 5 and 1/5 if you wanted to have it as a mixed numeral. Right, our last example is this one here. So we've got solve w over 7 plus w over 3 equals 4. So again, we've got two fractions. So let's get rid of them one at a time. So if we're going to get rid of this divided by 7, that means we're going to have to multiply by 7. But it's really important that we multiply every single term by 7. So we're going to multiply by 7 here to get rid of that 7 in the denominator. Then we're going to have to multiply this term by 7 as well, and this term on the other side of that equal sign too. So that times in by 7, 7 times w over 7. We'll cancel out the 7s and we'll just be left with w. We've got w over 3 times 7. That means we're going to end up with 7w over 3. So we're multiplying the numerator by 7, but the denominator stays exactly the same. And then on the other side of that equal sign, 4 times 7 is 28. So now we've got rid of one of our fractions, we're going to get rid of the other one. So to get rid of that divided by 3, we're going to times by 3. But if we do that, we have to do it to every single term in that equation. So we'll times everything by 3, and we'll end up with 3w plus 7w equals 28 times 3, which is 84. And that's going to give us 3w plus 7w. We know that that simplifies down to 10w equals 84. And then we'll just divide by 10 to get w on its own. And we'll end up with w equals 8.4. Again, don't forget that to check your answer. It's really good with equations that you always know whether you've got it right or not. So we can put 8.4 over 7 plus 8.4 over 3. And we should get an answer of 4. So that's a few examples of some more complex equations involving fractions.